Hello, hello. How we doing today? Hopefully, you took today to get out and do something that you really enjoy doing. And if you haven't, make sure you do that by the end of the day. We are doing 1-7, all about writing proofs. This is a fairly detailed lesson, and so I'm actually going to split this into two videos, okay? We're going to have one video just for all this vocabulary and theorems because there's a lot going on, right? Look at that, 2, 4, 6, 8, 9 different theorems and postulates, 5 new vocabulary. So this video is just going to be about all of these different theorems and properties and things like that, and then we'll get actually into the meat and potatoes, as they say, of the lesson. So if you're looking for the lesson, you'll want that next video, but for now we need to go to the bottom, the back of our notes, and find the vocabulary page, and we're going to do the vocabulary first, and then we're going to go ahead and do the theorems and properties. So go ahead and turn to that back page. Alrighty, so we have these last 4 vocabulary. I realize that linear pair is not on here, but we can talk about that when we get to it, and that should be pretty self-explanatory here. We're going to start with defining what is a proof. Okay, so a proof is a convincing argument that uses deductive reasoning. So what we mean by that is we take statements that we know are true, right? So we can find other statements in whatever particular problem we're trying to prove, and those statements will help us actually prove whatever it is that we're overall trying to prove. So convincing argument that use deductive reasoning. So these are going to have a lot of statements to them and a lot of different pieces. Okay, specifically a 2-column proof is what we're going to use the most. And so a 2-column proof obviously has 2 columns. Okay, and on the left-hand side of those columns, we have our statements. Ooh, barely fit it. Okay, we have our statements. So I can state that an angle is 90 degrees. Okay, but I have to have a reason for stating that. I can't just look at something and say, oh, that's 90 degrees. Okay, I have to have a reason. So on the right-hand side of that column is our reason, or I guess reasons, right? Because there's multiple. And then they're usually listed like 1, 2, 3, and so on. So that's going to be the 2-column proof. So we use that actually most often. A paragraph proof here is a proof where instead of in column format, we just write everything out in sentence format. So we're going to look at both of those in this lesson, but the 2-column proof is going to be the most common one that we use. So looking at, that's it for our terms. So I'm going to keep going down until we find all of our theorems and properties. Alrighty, so here we are on our postulates, theorems, and formulas page, and we're going to be looking at a lot of different things here. So pause the video as often as you need to, write it down. If you need to look things up or ask questions, make sure you check in with your teacher, because we got a lot of stuff going on, okay? So the first theorem we're going to look at is called the vertical angles theorem. So this says if angles are vertical, then they are congruent. And what we mean by vertical, and I'm going to draw it, and I don't have access to black ink for some reason, so we're just going to have to use a wide variety of colors. So, okay, so here's 2 lines. If I have, let's say, this angle, hopefully you can see that color, okay, right? There's an angle. Vertical angles are always just across from each other. So in this case, these two angles are directly across from each other, so they are the same measure. Okay, and then using that same idea, this angle is directly across from this angle. So those two angles are congruent. They are the same, okay? If I draw this, maybe we'll draw it with numbers instead of colors. So if I label this like angle 1, angle 2, angle 3, I'll just go around, and angle 4. Okay, so we can say that the measure of angle 1 is congruent to, actually, sorry, because we're using angle measure, we don't need the congruent. Okay, so the measure of angle 1 is equal to the measure of angle, and then what angle is across from 1? And it's 3. And then also we can say that the measure of angle 2 is equal to the measure of angle across from 2, which is 4. Okay, so that's vertical angles theorem. We use that a lot. So if that's not making sense, please check in with your teacher, because we use most of these theorems, we actually use quite a bit. Okay. The next one is congruent right angles theorem. So this is kind of funny, but it is still a theorem and we have to use it in our proofs. But this says if the angles are right angles, then they are congruent. Meaning if I have two angles, oh, I can do better. So sorry. There we go. If I have two right angles, and I know that they're right angles because I'm going to draw the little squares in, and this is angle 1 and this is angle 2, let's say. I know for a fact that the measure of angle 1 is equal to the measure of angle 2. And that's literally all it's saying, is that if I have two angles that are right angles, their measures are the same. And we know that because their measures are 90 degrees, right? So hopefully that's makes sense. It's kind of a little counterintuitive, right? Because we know that they're the same if they're right angles, but it's just a theorem that we need to know. Okay, the next one is congruent supplementary angles theorem. Okay, so this says if two angles are congruent, so if two angles are the same measure and supplementary, then each is a right angle. And so remember that supplementary is a term that we use, oh boy, I can do much better than that. It's a term that we've used in middle school, I believe I want to say. But just as a review, all it means is that two angles add to 90 degrees. Okay, so supplementary, right here. You need to make a note, Two angles. It doesn't even have to be two, actually, so let's just say angles. Angles that add, did I say 90 before? I'm sorry. To 180 degrees. Angles that add to 180 degrees. So then this is saying if I have two angles that add to 180, okay, so two angles that add to 180, and those two angles are the same, then this has to be 90 and 90, because 90 or 180 divided by 2 is 90, right? So if this is angle 1 and this is angle 2, we can say that the measure of angle 1 is 90, and the measure of angle 2 is 90. So then therefore the measure of angle 1 plus the measure of angle 2 is 180. So that's what we're saying here is if I have two angles that add to 180 and those two angles are the same, then each angle has to be 90. So hopefully we feel good on that. I'm going to go ahead and clear this page and let's keep going. Woohoo! These probably should have been flipped, but that's okay. This says if linear pairs theorem, if two angles form a linear pair, then they are supplementary. Again, remember that supplementary means you add to 180. Okay? So if two angles form a linear pair, then they are supplementary. So let's draw 180 degrees. It's not totally horizontal, but it's still 180 degrees, right? And I'm just going to draw a random line coming up, and I'm going to call this one angle 2. I don't know why I went backwards, but it's cool. Okay, so because these two angles add to 180 degrees, they are a linear pair. So, right, same thing, measure of angle 1 plus measure of angle 2 equals 180. So angle 1 and angle 2 are a linear pair. Okay, next one, addition property of equality. Now, the addition, subtraction, multiplication, and division properties of equality are things that you already know how to do. You just maybe didn't know what it was called, okay? So the addition property of equality just says if you add something to one side, you must also add it to the other. So like, for example, if I have like y minus 12 equals 23, I'm just making stuff up here, okay? This is saying, hey, if I add 12 to the left side, I also have to add 12 to the right side, right? And then in this case, I get y equals 35. Okay, so it's if I have like a equals b, and if I add 4 to one side, I also have to add 4 to the other side. That's all we're saying. If you add something to one side, you have to add it to the other side. And that's called the addition property of equality. Okay, same thing with subtraction property of equality. Okay, if I subtract something from one side, you must subtract it to the other side. So if I have like 5 equals x plus 7, right? If I subtract 7 from the right side, I also have to subtract 7 from the left side. That's all it's saying. So I get negative 2 equals x. So this is how we use it. Like this is how you've seen it before. So same thing, if I have a equals b, right? These two things are equal. Well, if I subtract 3 from one side, then I also have to subtract 3 from the other side. That's all it's saying. Same thing with multiplication, right? If you multiply something to one side, you have to multiply it to the other side too. So if I have like w over 3 equals 12, right? To get rid of this 3, I would multiply it to the left side. But if I multiply it to the left, I also have to multiply it to the right. And I get w equals 36. Same thing here, a equals b, right? If I multiply by 5, so 5a, I also have to multiply by 5. Hopefully we're feeling good. Again, these are things that you guys know how to do. You just probably didn't know what it was called. Okay, just a couple more here. Here we have the division property of equality. Same thing. So if I have 8x equals 64, if I go to divide something to the left side, I also have to divide it to the right side. That's all it says. And I get x equals 8, right? Or same thing here, a equals b. But if I divide like a divided by 6, then that I also have to divide b by 6. Cool. Okay, and then the last one is the transitive property of equality. So what this is, if two line segments are equal in length, then they are congruent. And I know that that seems really weird, right? If two lines are the same length, then they're the same length. Like, duh, right? But this actually comes up quite a bit. And the same thing for angle measures. If two angle measures are the same, then they are congruent. So what this means is, like, let's do a line segment example, and then let's do a angle example. So if this line segment, let's call it AB, let's call this one CD. Okay, so if AB is equal to 4 units and CD is equal to 4 units, right? So if these are the same length, because one AB is 4 and CD is 4, then I can say that AB is equal to CD. Or sorry, congruent to CD. So it seems funny, but it actually comes up quite a bit, and you'll see examples of when we use that. But I can do the same thing with an angle measure. So angle, angle. Let's call this angle 1 and angle 2, okay? So if the measure of angle 1 is 42, and the measure of angle 2 is 42, then we can say that the measure of angle 1 is congruent to the measure of angle 2. So if this one is 42 and this one is 42, then they are the same. They're the same angle measure. They're congruent. If this is 4 and this is 4, then they're congruent. They're the same length. Okay, so if you have any questions on any of this vocabulary or anything like that, please make sure you reach out to your teacher, let us know, let us help you right away, because we really don't have a whole lot of time with you guys. And so even just one day will make a huge difference, okay? So make sure you reach out to us right away so that we can help you.